Good morning, 7th graders. Sorry I can't be with you today. Let's get started on the lesson. Go ahead and fill in your information first. All right. So we just finished up equations. We're going to move on now to inequalities, and I want to give you just an introduction to inequalities. I know you've seen these before. You may not remember that you've seen them, but you have. And so we're not going to be getting into solving two-step inequalities for a few days. We're just going to get some background information. So let's go ahead and first write down the definition for inequalities, and then we will, and then we're going to, hold on just a second, I'm trying to pull up my notes. And then we're going to fill in this chart right here that's going to help us with understanding inequalities. So let's go ahead and put our definition first. Inequality compares two expressions using less than, greater than, less than or equal to, greater than or equal to. Okay, so those are the symbols that we're going to be using to compare those two expressions. So let's look at the meaning of each of those symbols. I'm sure you remember things like the alligator eats the bigger number and things like that from when you were young. Okay, so this symbol right here, we would say this less than, or is less than. So is less than. So we would say whatever is over here is less than whatever is over here. And some common phrases that you'll see when you're dealing with less than is fewer than or below. If you see those keywords, you're probably dealing with less than, and that's the symbol that you would use. The next symbol is the opposite of less than, and that is greater than. So we can say that we can read this symbol is greater than. And we would say this is greater than this. And some key phrases here that you might see when you're reading a problem is more than, or above. And we're going to see examples of those problems here in just a minute. Let's look at that next symbol. It looks like this symbol, but it has a little line underneath it. That little line adds a little something to this. So we can say this symbol is red is less than or equal to. Sorry, I ran out of space then. There is less than or equal to. And some of the phrases that you might hear or see is at most. So you can invite at most 10 people to your party. Or no more than. No more than 60 people can fit in the room. All right, let's take a look at that last one. It is the opposite of this one right here, and it goes along with the greater than symbol. We call this one is greater than or equal to. Okay. And some phrases that you might see where our at least, he has to complete at least 3 assignments a day to get caught up, or no less than. He has to have no less than $300 to open up a savings account, okay? So now that we have our table filled in, we're going to use that information to help us write some inequalities. So let me move my paper up a little bit. I still want to see that chart, so I'm gonna move it up just a little bit. Okay, it says the capacity of an elevator is at most 12 people. Okay, so here is our key phrase, at most. Let's see where we've seen that before. Right here. So we can use that less than or equal to symbol on this, okay? Well, before we do that, we need to define our variable. And the way that we do that is, I know in the last unit I said just pick a variable. Any variable will do. But I want to actually show you how to define it so that your reader can understand why you chose the variable that you did and what it represents, okay? So we're going to define the variable like this. We're going to say now we're talking about people here. So I'm going to let P equal the number of people. Okay, so that's how we define the variable. We're just basically saying what the variable is and what it represents. Now we've already identified what symbol we need to use. So the number of people in the elevator, P, is at most 12 people. Well, at most is less than or equal to. And really think through this, okay? At most 12 people. So that means it can't be any more than 12. So that's why we use that less than symbol. And then at most 12 means that it could be 12. And so that's why we also have that equal to piece there. And then 12. So this right here is our inequality that represents this situation. People, or P, is less than or equal to 12. So the number of people in the elevator has to be less than or equal to 12. Okay? I hope this is sinking in. Next problem, let's take a look here. There are more than 1,000 books in the library. Okay, we're looking at books here. So, and it says more than. Since it says more than 1,000, it can't be 1,000 because it's telling you it's more than 1,000. So that's what we're gonna roll with here. And we can also, let's see, more than right here, more than 1,000. So that is greater than symbol that we're gonna use. So let's define our variable. So we're gonna let B, sorry, I lost track of what I was doing. P equal the number of books. So we're gonna let B equal the number of books. And this phrase tells us that B, the number of books, is more than 1,000. So we want this symbol right here is greater than 1,000. Okay, so the number of books is greater than 1,000. All right. I'm gonna give you a minute. I want you to try these other two. So pause the video, give it a try. When you feel like you have it, play it again and see if you were right. All right, let's take a look at this. Hopefully you've had a chance to do it. There are no more than 60 people in the theater. Okay, let's define our variable. So we're gonna let P equal the number of people in that theater, okay? And no more than, if I look at my list, no more than is right here, which means that this is gonna be less than or equal to. which makes sense, right? We want the number of people in the theater. It can't be any more than 60. So it has to be less than 60, but it can't, the way that this is phrased, it can be 60, but it can't be any more than 60. And so our inequality looks like this. I hope that's what you got. A reminder too, whenever you're watching a video lesson, you can always pause it and rewatch something if you didn't quite catch it, okay? Let's take a look at this one. The temperature of the water is above 72 degrees. Okay, we're talking about temperature here. So let's define our variable. I'm gonna say let T equal the temperature. I'm not gonna write the whole thing out. Now notice when I do my variables, when I do T variables, I add a little tail to it. I do that so it doesn't look like a plus sign. So if you're ever wondering why my T's have tails, that is why. Now in this case, the temperature of the water is above 72 degrees. It can't be 72 degrees because it's telling us that it's above that. So the temperature of our water, T, is going to be above or greater than 72 degrees. So that is going to be the inequality that represents it. All right, here's what I want you to do. I want you to pause your video. I want you to go into Otis and click on the homework. The homework covers these problems, like these 4 problems. I want you to take a break from watching the video. I want you to do your homework. Then I want you to come back and continue playing the video because I'm going to move on to the next part. And then when Mrs. Lakey and I are both back, we are going to pull small groups and just make sure everybody's good with these skills. So let me flip my paper over. You pause your video and start it again after you're done with the homework. Oops, I guess my page isn't two-sided, it's 2 separate sheets. Your pages are 2-sided. Okay, so let me go ahead and write, so now we're actually gonna be graphing here. And I wanna make sure that first we define what a solution set is, because you know, when you did equations, you had one and only one solution that worked in that equation. Inequalities, it does not function the same way. Inequalities, there's tons of solutions. If you look back at this page right here, it says the capacity of the elevator is at most 12 people. Well, you could have no people in the elevator. You could have 1, 2, 3, 4, 5, 6, all the way up to 12 people in that elevator. So that's why we call it a solution set. It's not just one answer, it's a series of answers that all work for that problem. Okay, so a solution set is all of the solutions of an inequality. Oops, I need to make sure I spell that correctly. Okay. Now, I know you've seen inequality graphs before. You just may not have, you just may not remember until you see me do it. So let's talk about open and closed circles for the graph, and then we'll actually graph it so that you can see. Here are our symbols. There's always 4 symbols. That will never change. All right. When you are graphing on a number line, you're going to put a circle on the number that's in your inequality, and then you're going to put an arrow either to the left or the right. Now, your circle actually gives information, okay? This is a less than symbol. So if we say that x is less than 4, it can't be 4. It's everything that's less than 4. So we used what's called an open circle. It's open, it's not filled in. Okay. Now greater than. So let's say that the number of people is greater than 20. Well, it can't actually be 20. It has to be greater than 20. So again, we used an open circle, and what that means is we're saying there's a circle on 20, but 20 can't actually be the solution. It's not filled in. So this is an open circle. Now when you get to the less than or equal to and greater than or equal to, those numbers can actually be solutions. So we're going to use what's called a closed circle, and that includes that answer. So this is a closed circle. And this would be like the number of people is less than or equal to 15. So it can be less than 15 or it can be 15. So we use a closed circle to say, yeah, it can be that, and it can be everything less than that. Same thing with our greater than symbol here. We use a closed circle. Let's say that the number of, I don't know, YouTube subscriptions I have is greater than or equal to 100, okay? So it's greater than 100, or it could be equal to 100. So this could be a solution. 100 could be a solution, so that's why we use that solid filled in circle, okay? All right, let's go ahead and write our inequality in. I'm gonna do the problem that I did with the people in the elevator on the other page. Remember how we wrote this inequality? P is less than or equal to 12, okay? We were talking about how the capacity of the elevator, and we said that the number of people in the elevator has to be less than or equal to 12. Well, if I look back at my list here, less than or equal to is going to be a closed circle. Why? Because 12 is a solution too. It could be a solution. It could be everything less than 12 or 12. So I'm going to do a closed circle on 12, and I'm going to do my arrow. We want everything less than 12 to be filled in here. Okay, so we're saying everything less than 12 here is a solution, could be a solution. Okay, that's the solution set. I don't need to go all the way to the end of the number line to say it just keeps going, okay? So that means 12 can be a solution, 11, 10, 9, 8, 7, 6, 5, and so on. All right, well, let's take a look at another example. You're not going to do homework on graphing inequalities until tomorrow. So it's good for you to start seeing this a little bit, and then Mrs. Lakey and I are going to work with you on it as well. Let's do this one. X is greater than -4. Now, because it's not equal to, we're going to use an open circle. That open circle tells us that -4 is not a solution. It is not. It has to be greater than -4. And everything that's greater than -4 is over on this side. 6 is greater than -4. 2 is greater than -4. So I'm going to fill in my graph this way. Okay. Just like that. And what we're saying is that this arrow continues on and it includes everything that is greater than -4. All right, let's take a look at another one. Ooh, let's mix it up a little bit. Let's do M is less than or equal to 1.5. Okay. Now let's remember where 1.5 is on the number line. 1.5, it's halfway between 1 and 2. I'll put a little line here down to say this is 1.5. Now, is this going to be an open circle or a closed circle? What you have to think of is can it be equal to 1.5? And if that equal to line under here is there, we are going to do a closed circle. closed circle. So we're saying, yes, 1.5 can be a solution. And then this is telling us that m is going to be less than or equal to 1.5. So it's everything that's less than 1.5. All right, so it looks like that. Okay, I want you guys to try one. Try that one. See if you can do it. If you need to pause it because you need more time, go ahead and pause now. Because this is not equal to 0, it's less than 0. 0 cannot be a solution. So we're going to put an open circle there to say we have not picked 0. 0 is not filled in. And then we're going to shade in everything that's less than 0. Like that. I hope that's what you got too. All right, you guys. So hopefully Miss Lakey and I will both be back with you tomorrow, and I hope that you learned a lot from the lesson today. And hopefully you've already gotten your homework done, so now you can relax. Have a great day. I'll see you tomorrow.